Anyway, yeah, can helium-3 save our ass? When I talk about asses, of course I do talk about donkeys. This is family-friendly entertainment. Yeah, let's talk about this guy, for example. It's just one of many. This is Robert Bigelow, actually a guy who has a lot of hotels and got pretty rich and is trying to go into space. And he wants to go to the moon and mine helium-3. And he made his very own, obviously self-drawn cartoon to show us the problem, supposedly. Yeah, he is obviously afraid of the Chinese. He's an American, if you didn't guess. Yeah. Quite terrible, actually, that cartoon. Yeah, helium-3 is going to save the world and essentially power everything. That's what a lot of the people try and say. Yeah. Is that realistic or not? Actually, it's well, we have to see if helium-3 can save our ass. If you're interested, see the whole presentation is this one. Yeah, helium-3. He's not the only guy who's talking about helium-3 a lot. ESA's talking about it. A lot of articles out there. ESA's talking about it. In fact, if you look at the whole page, there's exactly one. If you look at the first couple of search results for the helium-3 Apollo, there's one that is critical about it, and very similarly, if you look at helium-3 mining, there's a lot of hopeful talk of helium-3 powering the Earth for 10,000 years at least, or whatever. Yeah, so it's a real thing, and at least in terms of discussion, it's not so much a real thing in practice, and I'm going to show you why. Helium-3 is, as you can see, an isotope of helium. It's a light isotope of helium with just 2 protons and 1 neutron, and you can do nuclear fusion with it. Now, the hope is that you can do nuclear fusion with it that produces less radioactive waste. Some people say it produces no radioactive waste. That is not quite true, because actually you want to fuse helium-3 with deuterium, and as a matter of fact, if you look at the reactions, and yeah, you can have a look at the Wikipedia page on nuclear fusion, obviously, but you can also go to some other sources. This one's free for download. You can have a look at it, and you will find that there are many ways of doing nuclear fusion. That's the one everybody is trying to go for right now because it's the easiest, and this is an order of the most favorable ones. And now you might expect something like helium-3 that's supposed to solve all of our energy problems to be somewhere on the top, but it's actually somewhere here, and that might already tell you it's maybe not the easiest thing in the world, especially considering that even the easiest one hasn't been done yet. So that's one major question mark, and it's actually the smallest problem in helium-3 after all. To come back to radioactivity, problem with radioactivity is the neutrons. Neutrons interacting with other matter can easily produce radioactive isotopes and thus radioactive waste. This one looks promising. You have deuterium, helium-3, you get helium-4 and a proton, no neutrons involved. So what could possibly go wrong? Well, the problem is here with the deuterium can fuse with itself, and because in this reactor you will have deuterium and you will have helium-3, and you will not be able to just take the 2 of them and tell the deuterium atoms and the helium-3 atoms to fuse with each other and not let's say, a deuterium atom with another deuterium atom. You cannot tell them to do this. You will have both, and so you will get neutrons. You will get neutrons from the reaction of deuterium producing helium-3 itself and a neutron, and you will get them because you will produce tritium as well, and you will get this reaction as well, and thus also more neutrons. So it will never be free of neutrons, no matter what people tell you. So I told you it's harder. Let's have a look at how much harder. This is from the document I've showed you. How much harder? You can find this essentially here. And yeah, this is how much power you will get out of a given sized reactor, provided that it works and you have a proper fusion reaction going. You will get about 80 times as much energy out of the usual deuterium and tritium reaction. No, almost 100 times as much energy compared to helium-3. So it's almost 100 times as difficult to build a proper reactor for helium-3 fusion, and that's the easy problem. And it's just physics. Maybe one day we will be able to build fusion reactors that are really small, that are incredibly powerful, and for whatever reason we will be able to do helium-3 fusion with a compact and economical reactor. So this may possibly be solved, just a matter of engineering. What is not a matter of engineering is how much helium-3 there actually is. You have to get helium-3 in order to do helium-3 fusion. And you can just use Google Scholar, and yeah, in this case it's actually just the very first hit that you will get, and it's helium-3. And yeah, what you can find is those are the results of the soil samples taken from the Apollo missions. And if you have a look at this one, this is helium-3 abundance in parts per billion. And this is a 10. This is not 10 million parts per billion or something, it's 10. So this means that if you have let's say 1 billion tons of soil, you will get maybe 10 tons of helium-3. That's a major problem, because nuclear fusion produces a lot of energy, quite a lot, at least compared to regular fuels, but it's not unlimited. You can do the math, and you will find that compared to fission, where you need about 1 ton of uranium in order to get 1 gigawatt of electricity per year, roughly, you will need about 1/8 of that mass in terms of helium-3 in order to get the same amount of electricity. So you still need about 120 kilograms of helium-3 in order to run a nuclear power station for 1 year. And if you have, let's be optimistic and say you take these 10 parts per billion and you're mining this stuff, well, it takes about, you need about 10 million tons of soil, of lunar soil, in order to get the necessary amount of helium-3 to have your power plant run for even 1 year. Now that's very similar to something that is going on right in this area, and I can show this on Google Maps quite easily. This is Leipzig. We are somewhere here. All these lakes here, those are not natural lakes. This is lignite mining. There are landmines. No, not this one. This is a big one here. I'm actually from this little town here, so I know what this is all about. And you need about 10 million tons of lignite in order to run a similar coal station. So essentially, when people are talking about mining helium-3 on the moon and powering power plants down here on Earth, what they suggest is, well, let's do something on the same scale as coal mining on the moon, just in order to produce a little bit of helium-3, ship it back to Earth, do something that is nuclear fusion, a kind of technology that we are really not quite able to pull off yet, and save our ass. Well, I like that little ass that I've shown you, and I don't think that this way we can save our ass. Thank you.